Okay, good night. I'm sporting my Tigers hat tonight because they're the best baseball team in the MLB, excuse me. All right, so we're going to start off with your date here. And tonight's video is about combining what we learned about domain and range and continuous and discrete graphs. Okay, so this is where it gets a little bit harder. Discrete for a domain and range have specific points, right? So the discrete graphs are actually quite easy to find because it's just a point, right? So if it looks like that, it's just those x's and those y's. So if we go to our example here, all I have to do, and I saw some of you guys do this in class the other day, which was really great, is write my coordinates down. So here I have negative, let's see, 1, 2, 3, 4, 5, 6, negative 6 and 4. And then I have, this looks like negative 4.5 and negative 3.5. And then here that looks like negative 3. And then this is negative 3. And then here we've got negative 1.5. And then here we've got negative 2.5. And then here we got 0, negative 2. And then here we got about 1.5 to negative 1.5. And here we have 3 and negative 1. And then here we have 1, 2, 3, 4, 5, and that looks like negative half. Okay, and so then really we can just say, instead of listing this out, if we were just working on this as a problem, we could just say this is my range and this is my domain. And actually I think I saw someone in class the other day just put right here D and R. Okay, so the discrete are easy. It's just those points are the domain and range. Those are the only points in there. However, when we get to continuous graph, it gets a little trickier because a continuous graph includes the points, but all the points in between those specific coordinates on the graph, right? So it's not just these 3 points, it's all the points between them as well. Okay, so that's where we're going to write more of a boundary. I mean, you could never write all those numbers to infinity. So if we look at this example right here, the domain is the x, right? Okay, so we have some, specific points that we can pick out. You have a point here, and you got a point here, and you've got some real nice points here. But we also have all the points in between. So like if we looked at this point, 1, 2, 3, 4, 5, that's negative 5 and negative 2. We also have to include this point right next to it here, which would be like negative 4.9 and negative 2 and negative 4.8, all these little pieces in between. So we do a range. So if I look at this, here's my x, right? And it's going forever in the left direction. So it's going to cover, my graph will cover all negative x's. And then if I look at this, this is gradually going to the right forever. We talked about this in class the other day. It doesn't ever just straighten out. It's at an angle. So it's going to keep going this direction. So we can say it's going forever to the left and forever to the right. So it covers all negative x's and all positive x's. So when we do the domain, for this we'd say domain is, we could say x, because x is the domain. And we can say, if we look at this point right here, that's 0, negative, we'll say 1.5. So x is greater than or equal to 0. So the point is here, and it covers all points going to the right forever. And we can also say x is less than or equal to 0 because it goes forever in all the negatives. Okay, that's a little bit hard. But it's going forever in the right and left direction, and the x-axis is to the left and to the right. The y-axis is up and down. Okay, so this goes forever to the left and forever to the right. We can also say this is just all real numbers. Okay, because there's never a point on the x-axis that it's not going to be on this graph. okay? Because it is going forever from here over, and even though it's a little more slowly, it's still going forever to the right. Now the range is a bit different. The range is your y-axis, right? So we have y. So that's your up and down, okay? Well, if I look at this graph goes no lower than here, and that's the -2 on the x-axis, right? It doesn't go any lower than this point here. And then it goes up forever. So, and it doesn't go anywhere down here. So for my range, I can say y is greater than or equal to 2. Because here are my points. You know, this is -5, -2, -4, -2, -3, -2, -2, -2, -1, -2, and then 0, -1.5. So it starts going up right here. So lowest it goes is, -2. So for my domain, I would say all real numbers, and then for my range, I would say it's -2 and greater. Okay, this is a hard concept for a lot of people, so we're going to work on this a bit. Let's look at one more example here, and then I'm going to ask you to try 2 on your own. Okay, so the first thing I'm going to see is I'm going to look at my x-axis here. Okay, and I'm going to say, is there any part of the x-axis that this doesn't go on? Okay, so I can see it goes this way. The arrow indicates forever, so it's going to go in the negative direction forever. And then here it's going in the positive direction forever. And in 9th grade, most of our domains are going to be all real numbers. I won't say all, but majority of them. Okay. Now let's look at our range. Our range is our y. So I want to say up and down. So up and down, the highest this graph goes is here, which is 0 on the y, and then it goes down forever. Okay? So my range is going to be y is less than or equal to, because it actually touches the 0, so I have the equal to 0. Okay? So that's kind of a brief introduction to it. I want you to try to find the domain and range on the next couple here, and let's just see where we're at, and we will spend some more time on this. Okay, so looking at, this problem right here, I would like for you to list the domain and range of this one. And then I would also like for you to try this continuous graph. It's a little bit harder. Find the domain and range of the continuous graph. And I think, yep, that's it. Okay, so give it a go. We'll go over it in class.